Math 2, Section 3.8b. So today we're going to go ahead and continue on and talk a little bit more about translations, reflections, rotations. So if you look here at 1a, we have segment GH. And so the instructions are to translate that 3 up. So from G and H, we're going to go 3 up. And we'll make our G prime and our H prime. And you can go ahead and get out your rulers or your ID cards so you can make your lines straight. And we have our prime segment. And so the ordered pair for G prime, if we count over, this goes 6 and then up 4. And H prime is 1 and up 3. And so we talked about this yesterday as well, but any point on segment GH representing X and Y translates on G prime H prime to what? And if you notice here, see how the X's stay the same? Here the X's stay the same. So the X stays the same, and then up and down, remember, goes with the Y axis. And so we take whatever our Y value is and we are adding 3 to it. So Y plus 3. Slope is rise over run. So on G and H, if we count how many it goes rises or goes up, that's 1. And then it goes over 1, 2, 3, 4, 5. And the slope is the same for the prime segment. Another way of writing a translation, and we talked about this yesterday, is that you can put a T, so that means translate. And then this first number goes with your x-axis, which is right and left. And the second number goes with your y-axis, which is up and down. So this one is asking us to shift this or translate it left 2 and up 4. So we're going to go to J and go left 2, up 4, and make our J prime. And same for K, left 2, up 4. And we have K prime. And then we can draw our segment. Okay, so the ordered pair for J prime is -6, 6, and K prime, it is at -3 up 2. If we look at the slope for JK, it is going 1, 2, 3, 4 down, so that's -4 down, and then right 1, 2, 3. The same is for our J prime, K prime, -4 over 3. It's important to remember that when you have lines that you read them going from left to right. And so when you read this left to right, you can see that it is going down, which is why it's negative. On this KG here, it's going up, so that is a positive slope going from right to left. Okay, here when we see R, and again, we talked about this yesterday, that means reflect. And specifically, you can see that it's saying reflecting over X equals -1. So what we would want to do is go to the line X equals -1, which is right here, and draw a line. And we talked about yesterday how when we're reflecting over a line, we want to count the distance the point is from that line. So if you look here at M, it's 1, 2 away. So we're going to count 1, 2 away, and that makes M prime. L is 1, 2, 3, 4, 5 away. So we count 1, 2, 3, 4, 5 away, and then we have our L prime. Okay, the ordered pair for our L prime, for L, is 4, right 4, and down -3. And for M prime, it is right 1 and down 4. The slope of line LM, if you look, it goes up 1, which is a +1, and then left 1, 2, 3, -3. For the prime, it goes up 1 and right 1. So if you notice here, and if we were to read these, see how this line is going down, which makes it a negative slope, and this line is going up, which makes it a positive slope. So when you have a reflection, you get an opposite slope. All right, moving on to number 10. On this one, we are going to rotate it counterclockwise. So it's important to remember the difference between clockwise and counterclockwise. So clockwise is, if you think about a clock, clockwise is going to the right. So we're turning right. Where counterclockwise is going left, that direction. So on here, they want us to rotate this triangle 90 degrees counterclockwise about the origin. So the origin is this point right here, which is 0, 0. And this also can be written as 90 degrees, comma, O for origin, okay? So when we rotate 90 degrees, we talked about this back in Unit 0, but we are rotating our paper one turn for each 90 degrees. So since it's counterclockwise, I'm going to turn this left 90 degrees. So that'll be left one turn. So we go one turn, and my new triangle should end up being in quadrant 2 when I remake it. And in fact, I'm going to go back this way. Your quadrant, so we can kind of talk about it, it goes quadrant 1, 2, 3, and 4. Okay? And so I'm going to go ahead and label for my prime points. So we're going to have A prime, and we'll have an ordered pair, and B prime will have an ordered pair, and so will C prime. Okay, and so when I make this counterclockwise move and I turn it 190 degrees, this is where my new triangle should be. If this were quadrant 1, 2, 3, 4 like this, it should be in quadrant 2. So we're going to label these ordered pairs. So A, as an ordered pair, it goes left 6 and up 1. So for my A prime, I'm going to go negative 6, 1. For B, it's at 0, up 1. And C is at 0, up 1, 2, 3, 4. So once I have those points, I'm going to go ahead and turn my paper back, and then we're going to go ahead and plot them. And we know it should end up in quadrant 2 because we kind of discussed that when we turned it the first time. And we're just going to label those points. So we have negative 6 up 1, so we have now our A prime. 0 up 1, this is my B prime. And then 0 up 1, 2, 3, 4 is my C prime. And we can draw our 90-degree reflected triangle. Another thing I just wanted you to compare real quick is if we take the original points of A and B and C, my original A is right 1 up 6. My B is right 1 up 0. And C is right 4 up 0. So you can see that there are similarities in the points, but things change from X to Y and negative to positive when you are doing rotations. Okay, so number 3, this time it asks us to rotate it 180 degrees clockwise. So 180 degrees is how many 90s? Okay, so hopefully you said 2. So 180 is 2 90s, so that means we're going to be turning this 2 times. Okay, so I'm going to write down D prime, E prime, F prime with my ordered pairs. And we're going to go ahead and do our rotation. So clockwise means I'm going right, so we're going to go 1 turn, 2 turns. And so when I do my 2 turns, if this were how it was supposed to be on the paper, we'd know that the triangle ends up being in the 3rd quadrant. So because it's upside down, I'm just going to take another piece of paper and write what my new ordered pair should be. So D should end up being negative 2, 0, because it's left 2 up 0. E is at -6 up 0. And then F is at -6, -6. And so I'm going to go ahead and turn this back around here. And we'll go ahead and mark our points. And so we have -2, 0, -6, 0, and -6, -6. And we'll plot those points. So -6, -6, F prime. -6, 0 is E prime. -2, 0 is D prime. And -6, -6 down here is F prime. And you can see that it did end up in quadrant 3. If you don't like turning the papers and that doesn't make sense to you, you could always use patty paper as well for this. So there is patty paper that you can go and get if you would like to. For this next one, number 4, I find that patty paper actually works the best because I don't have a coordinate plane to see what's happening when I'm turning it. And so if you get one piece of patty paper for each of your groups, you guys can share the same piece of patty paper so that we're not wasting. If you're at home and you don't have patty paper when you're doing these, you can actually use a piece of white computer paper and you can see this stuff through it as well. So when I use my patty paper, I go through and you can see here I've already done it once, but we mark our point P there. And then you go and you draw your line from A to B so that you have the correct distance. 90 degrees clockwise means I'm going to turn this 90 degrees to the right or 90 degrees to the left. So clockwise, if you didn't say it, means going right. So I'm going to keep this at point P and I'm going to turn this paper 90 degrees, which means I'm going to turn it one turn. Okay, and so you change it. See how this side is up here? We do a complete turn on my point P, keeping it at point P, and turning it 90 degrees, one turn. And then you just draw on that line so that we can see it through the paper. And then I'm going to mark that that is A up there. And so you can see on your paper where you're supposed to draw. And so we have A to B. And it might have been better to use a ruler for that, but that's how it is. And so then others in your group can use the same patty paper, make sure that they line it up correctly, and then do your 90-degree turn, and you can see that it lines up there. Okay, moving on to number 5. Now, this one says 270 degrees about the origin. Okay, notice on this one, the 270 is in the front. If you go back and look at number 2, also they had the 90 degrees in the front. And so that 90 degrees when it's there, that means counterclockwise. If it had been in the other spot, it would have meant clockwise. So let's go ahead and just write that this means 270 degrees counterclockwise. So 270 degrees is how many 90s? Okay, so hopefully you have stated that it's 3 90s. Okay, so counterclockwise, I'm going to end up turning this 3 times. So here we go. We go 1 90, 2 90s, 3 90. Okay, and so we end up where my quadrant, if you look here, this triangle is in quadrant 2 once it ends up turning. And so I'm going to go ahead and write my points here. So we have N, M, and P. So N prime is at -1, +1. M prime is at -1 and up 1, 2, 3, 4. And P prime is at -1, 2, 3, 4, 5. And up 4. So I'm going to write those and then I'm going to turn my paper back And we'll write them here. So n prime was negative 1, 1. M prime is negative 1, 4. And P prime is negative 5, 4. And then we need to go and plot each of those points now that my triangle is back to how it was originally. So the 270 degrees then is at negative 1, 1 for my n prime, negative 1 up 4 for m prime, and then P is at negative 1, 2, 3, 4, 5, up 1, 2, 3, 4 for P prime. And then we can draw our triangle. So the last question there, it says describe another rotation to create the same image. So to still get the image here, what other way could you rotate it? And so think about, we have counterclockwise and clockwise. So if we did 270 degrees counterclockwise, I got the figure here in quadrant 2. So how many turns would you need going clockwise in order to get it into the quadrant 2? And so if we play around with it, so clockwise turning at 1 time, do you see how there it's getting into quadrant 2? And so 90 degrees clockwise will get you the same results as 270 degrees counterclockwise. Okay, we're going to go ahead and move on to the next page, number 6. Okay, so number 6 asks, state the rule to create the image. Okay, so this is the original image, and then it gets translated into quadrant 2. And so what would we have to do in order to get this figure to move here? How would I rotate it? And so I would play around with your paper. So we're looking at this figure right here, and if you want to, we could kind of color it in so that we see kind of what's going on. And we want this to move into quadrant 2. So it's in quadrant 1, move to quadrant 2. So let's start going counterclockwise, and how many times would I have to move it in order to get into quadrant 2? So we move it 1 time, and look, it is already in quadrant 2 because they go 1, 2, 3, 4. And so what kind of turn was it that I just made? Okay, hopefully you said a 90 degrees counterclockwise. So the other question is that what would be a different rule to create that image as well? So instead of going counterclockwise, how many turns would I need? Because every turn is 90 degrees. How many turns would I need in order to get it here, but going clockwise? And so we're trying to get it into quadrant 2. So if I start going right and I make 1 turn, it's not in quadrant 2. So I'm going to make a second turn. Okay, it's still not in quadrant 2, so I've had 2 turns. And then 3, it is now in quadrant 2. So I made 3 turns. So 3 times 90 is 270. So the different rule would be 270 degrees clockwise. Okay, number 7, it says, what do you notice about the coordinates of KLM compared to the points KLM? So let's go ahead and write these down. So K, the ordered pair, is at 2, 5. L is at 5, 2. And M is at 2, 0. So then for K prime, it's at negative 5, 2. L prime is at negative 2, 5. And M prime is at 0, 2. So what do you notice about the coordinates of KLM compared to K prime, L prime, and M prime? Okay, so I notice that X and Y all have similar numbers. But the numbers exchange between X and Y or become opposite, meaning positive to negative or negative to positive. So do you think this will always be true for any rotation? Maybe discuss this in your groups. What do you think? So will this always be true? No. It will always be true if it's about the origin. So yes, if it is about the origin. No, if it is about a different point. Okay, so last one, number 8. Number 8 asks us to translate our triangle ABC by moving it -1, so left 1. If you need to write that because you don't remember, that means right and left. So -1 is left 1, and then 5 would be up 5. So we're going to go ahead and take this figure, and we will take the A value, and we're going to go left 1 and up 1, 2, 3, 4, 5 for A prime. B, we go left 1, up 1, 2, 3, 4, 5. And C, left 1, up 1, 2, 3, 4, 5. And then we'll go ahead and draw this. Okay. So then the next thing it says for our double prime is that you are supposed to take this, so it says take this figure and reflect it across the y-axis. Okay, and so again, whenever I'm doing a reflection, I think it's a good idea to maybe highlight or draw a line somehow of what you're reflecting over. So here we're going to reflect over the y-axis. So is B going to change? No, because it's already on the y-axis. So B prime is or double prime is also there. For A double prime, if we count, it's over 1, 2, 3, 4. So we're going to count 1, 2, 3, 4. And we get A double prime. And then C, we count to the y-axis, 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5. And we get C double prime. And we can draw our new figure reflected over the y-axis. And then it states that this could also be written as reflecting over the y-axis, so our y-axis for reflecting over the y-axis, and translating -1, 5. Okay? And so this is actually the double prime is your final answer. Okay, and then 8 says, write another rule to transform triangle ABC, so this triangle ABC, to A double prime, B double prime, C double prime. So what was something else, another way they could have done that? So hopefully you're kind of giving this a try on your own. So another way that this could have been moved would be that you could have started first by reflecting this over the y-axis. So we could have taken this figure and reflected it over the y-axis. So let's go ahead and do that. So if we take this, and I'm going to put reflect over the y-axis as first. So B is 1 away. So we're going to move this 1 away. So that's going to be, we're going to label that as just another B in a different color if you want to, or you could do B triple prime. A is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is my A. And then C is out 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So we have this figure. So we reflected over the y-axis first. And then in order to get it into that double prime spot, how would I need to translate this new triangle? And so I'm going to go ahead and write T here for translating. And you just have to choose one point. So I'm going to just pick B. What would I need to do to B in order to get it to this point? Because when I move B, that would translate everything else as well. So let's see. On the x-axis, how many would I need to go right or left? Okay, so for B, I'd have to translate it 1 to the right. So that's a positive 1. And then once I make it to this positive 1 here, I would need to then go up, which is positive 1, 2, 3, 4, 5. And so you'll notice here that this is a different translation than this, but they both get you to the same location. And that is it.